Hey guys, this is Shah here at the Tech Borg, and today's video we're going to be doing a factorial program, but I have done a factorial program before, but this is going to be a factorial program without recursion. Now, recursion is like using define program nested into another define program. So for example, we'll have define x, and then in that define we use another print define x minus 1, etc. So basically it keeps on looping in itself using a define function. Recursion, basically. It's like, if you guys have studied A-level or GCSE maths, you guys will know that recursion just means basically just going around in loops, basically. So for example, we can have a sequence, right, which will go around in a recursion. Like, there'll be a certain order, i.e. a Fibonacci sequence. Sorry, not a Fibonacci. Recursion is just continual repetition of a process. So we can go 1, 2, 3, 4. So in this case, we're just continuously adding 1. So that's a recursion in a way. For example, un, like a formula, equals un minus 1, the previous value of u, plus un minus 2, i.e. a Fibonacci sequence. You add the previous two terms to get to the next term. So we're going to do a factorial program with our recursion. Now, first of all, we need to obviously find out n, which is the value of the input factorial we want. So we want an integer input. Of course, can't find the factorial of a decimal number. Anyway, so enter whole number. Okay, now let's just put int around it, do this and do that. Okay, this makes sure it's an integer, of course. Now, I'm going to do something different now. So, we're going to first set up a while loop, yeah? So, while n, yeah, is greater than 0, i.e. because it has to be greater than 0. So, we're going to use a while loop to make this program. So, yeah. So, 0, and then we go boom, boom. Now, if you think about it, we need to times n by such a number, it won't affect its value as the initial value. So something times n will give us n, i.e. 1, right? So we need to make another variable called factorial, and call it 1. Okay, now I'm going to write out the code, and then I'm going to explain to you exactly what I did. So now, what I'm going to do is write out the code. So factorial equals factorial times n, and n equals n minus 1. So technically we're recursing, but we're not using the define method, so we're using a slightly different approach. This is a better approach according to me, but you know, whichever one works with you. And now we just print factorial. Okay, I know I haven't explained the middle bit, so I'm going to do that just now. So look, what I've done initially is, so we've set up a variable called n. Now what we've done is, we've called it n, and then we've done enter whole number, so they can enter the whole number, and we'll give an output, i.e. the answer, which is factorial. Now factorial equals 1 is vital, because now factorial equals factorial times n. So your factorial is your value, right? So the user enters 5, the output is your factorial. So the factorial represents your variable that will be your solution, i.e. your answer to the input. So when the user inputs something, i.e. let's say 5. So when the user inputs 5, our program will do factorial equals factorial times n. So it will do factorial 1 equals 1 times 5, because n equals 5. Therefore, the new value of factorial will be 5. Now, in the next loop, when it runs the while loop, it will be, so because we have n equals n minus 1, now n will equal 4. So factorial equals factorial times n. Your new factorial value will be 5, because remember 5 times 1 was 5. And now, because n equals 4, 5 times 4 is 20. So it reduces by 1 each time. So letting factorial equal 1 means you're using the base value of the actual number, and then reducing the value of it each time by 1, and timesing it through by the old one. So let me just repeat that in a more simpler, less sophisticated way, so it's easier to understand, less programming involved. So all we've done is, basically we found number 1, which when you time something by 1 will give you the same number, right? Which is what we want to do. So what we've done here is literally we've times, let's say pick a number x factorial. So x equals 1 times x, so x, right? X is your output, but now you can times it by x minus 1. And what this loop allows us to do is keep on timesing it by n minus 1, n minus 2, all the way down to 1. Think about it, n times n minus 1 times n minus 2, all the way down to 1. And that's it. That's all we've done. Nothing complicated. So what this does, well, this specific line goes down from n minus 1 all the way down to 1, because we've ensured that while n is greater than 0, it will keep doing this. And as for all of you that know, when n is equal to 0, n factorial of 0 is indeed 1. So yeah. So, but that doesn't matter, obviously, but, you know. And you can't have 0 inside your factorial, because remember, it would be 5 times 4 times 3 times 2 times 1. You don't obviously take into account the 0, or else it would be factorial 0, which is 1, and it will mix up the answer, because factorial 5 is 120, I believe. Yes, 120. So, yeah. 5 times 4, which is 20, 20 times 3 is 60, 60 times 2 is 120, and 120 times 1 is 120. So, yeah. And yeah, that's all we've done in this video, guys. I hope you guys enjoyed this, and this is Factorial Program without recursion. I've made a previous video where we did use recursion, so have a look at that if you haven't. And you guys comment which one you think is better. I personally think this is better, but obviously we all have our own opinions. And anyway, guys, thank you for watching, guys. I hope you guys enjoyed this. Oh, before I conclude, let us run this just so I can show you it's working. So if we enter 5, there we go, it's working. 120. Just so you believe me that it's actually working, let's just try a different number. 4. 4 factorial is indeed 24. You can check on your calculator if you want. And yeah, that's really it, guys. Again, I hope you guys enjoyed this video, and like, comment, subscribe.